measure of central tendency. And in the course of looking at this topic, this subtopic, we'll be looking at mean, median, mode, and range. Now, mean can also be referred to as average, or some people refer to it as arithmetic mean. Arithmetic mean. Now, what is mean? Mean is a total or a summation of a total series or a given series by the number of time they appear. Some people refer to it as the summation of the addition of all the values given in the distribution divided by the number of time they appear. An example is given as thus, where you have, says example, say determine the arithmetic mean given the following set of data. Okay? Set of data 2, 4, 8, 5, 6. Now to look for the mean here, mean I said is the summation of total series of a given distribution divided by the number of time they appear. Now, before we move further, I would like to say that in the course of this series, we'll only look at the mean for an ungrouped data. So we are concentrating only on an ungrouped data. Here we have 2, 4, 8, 5, and 6. We're asked to determine the arithmetic mean of this given series. So what we do is that we add all these series together, divide them by the number of time each value appear. So we have mean equals to, which is depicted as this, equals to 2 plus 4 plus 8 plus 5 plus 6 divided by number of time it appears, 1, 2, 3, 4, 5 divided by 5. So we add this together and divide it by 5. 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 5 is 19. 19 plus 6 is 25. So we have mean equals to 25 over 5. Therefore, mean is 5. Our mean here is 5. Now let's consider another example. Example 2 says given that the arithmetic mean of 4, 8, 6, x, 9 as 10, says determine the value of x. Now to determine the value of x here, we still need to apply the formula for mean. And we know that the formula for mean says that the summation of the total series of the distribution divided by the number of time it appears. So in solving this, we have mean to be equals to, because according to the form to the question says given that the arithmetic mean of this set of distribution as 10. So we have this set of distribution as 10. So mean here originally have been given to be 10. So we add this series together divided by number of time it appears equals to mean. So we have mean here equals to the addition of 4 plus 8 plus 6 plus x plus 9. divided by the number of times it appears. 1, 2, 3, 4, 5. So we have 5. Arithmetic mean here, which is equals to 10, pardon me, equals to 4 plus 8, 12. 12 plus 6 is 18. 18 plus 9 is 27. So we have 27 plus x equals to 5. Here, what do? We cross multiply. So it's over 1. So we have 27 plus x equals to 10 times 5. 27 plus x equals to 50. So we collect like terms. So we have x equals to 50 minus 27. X equals to 50 minus 27. Now we move to mode. Mode is referred to be the value that has the highest frequency. That is, in a set of distribution, when you have a value that appears most, is referred to be mode. An example is this: given a distribution of 2, 3, 5, 7, 2, 5, 7, 6, 2, 9, 8, 2. Now looking at this question, then you can now determine your mode. How do you determine your mode? You look for the value that appears most. Now in this question you can see that a value here appears most, which is, let's count it, 1, 2 for 2, 3, 4. Let's consider 3. How many 3 do we have in this set of distribution? 1. It's only 1. What of 5? 1, 2. Okay, what of 7? 1, 2. What of okay, 6 is 1. Even 9 is 1. So the mode in this set of distribution is equals to 2. Median. Median is a data valued midway after the rearrangement or rearranging it from ascending order or descending order. So here, to determine median, we need to arrange it from ascending, that is from the lowest to the highest, or from the highest to the lowest. Then we determine the middle number from the word median. Considering this example where we have 2, 6, 1, 5, 8, 3, and 7. To look for the median here, we arrange it from the ascending order or either descending order. So we have 1, 2, 3, 5, 6, 7, and 8. Now to look for the middle number here, the median here, so we count for the, well, we look for the middle number 1, 2, 3. Also from here 1, 2, 3. The middle number here is 5. So median is equals to 5.
Sure.
Now from this example you can see, if you count this distribution 1, 2, 3, 4, 5, 6, 7, you can see we have 7 number, which is an odd number. In the case of odd number, this formula is applied: n term plus 1 divided by 2. But in the case of even number, that is when you have a set of distribution that is uneven, you have the formula n term divided by 2. Take for instance, now in the case of even number, we add 2 values that are midway together and divide it by 2. An example is given as this, where you have 4, 2, 6, 5, 9, 8, 3, and 10. If you count this distribution, you have 4, 2, 6, 5, 9, 8, 3, 10. 1, 2, 3, 4, 5, 6, 7, 8. 8 is an even number. So we can rearrange this. So let's rearrange. If we rearrange, we have 2, 3, 4, 5, 6, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 8 now. So to look for the middle number here, we count 1, 2, 3, 1, 2, 3. So the middle number here we have is 5 and 6. So we add them together. 5 plus 6 divided by 2. We have here to be 11 over 2, which is 5.5. Let's consider another example on median. This time on a table. Given the distribution in the table below. Excuse me. X, F. Five, 10, 8, 12, 2, and 4. 20, 12, 15, 8, 10, and 16. From the table, it shows us that we have 20 5s, 12 10s, 15 8s, 8 12, 10 2, and 16 4. We are asked to look for median here. Median, mode, and mean. Now to look for median here, what we need to do is to prepare another table, a straight table, where we have X and F. We have 5, 20. We have 10, 12, 8, 15, 12, 8, 2, 10, and 4, 16. Looking at this question, we can also present this question because you can see that the value here are not arranged in an orderly manner. So we can present this in another way, where you have the list number 2, which is equals to 10, 4, 16, 5, 20, 8, 15, 10, 12, 12 to be 8. I want to believe all these values are well represented here. When we have a question like this, we add all the frequency, and by the time we add it, we have 81. So what we do is to go to the formula which says median equals to n term plus 1 divided by 2 in the case of an odd number. Our value here, our n term here is 81, so we have 81 plus 1 divided by 2, so we have 82 divided by 2, which is 41 position. So this 41 position is not the median. So before we get the answer, we go and look for the cumulative frequency to know where the position of 41 in this frequency. So we can add to get the frequency, cumulative frequency. What we do is to add the value of frequency from one level to the other. So we have 10, 10 plus 16 to be 26, 26 plus 20 to be 46, 46 plus 15 we have 61, 61 plus 12 we have 73, and 73 plus 8 we have 81. From here, 41 position here will fall between where there is 46 position here. So here is where our 41 lies. So we trace it to where the S is. So therefore our median here is 5. To look for mode is very simple. Mode here talks about the value with the highest frequency. The value here with the highest frequency here is 5, because 5 appears 20 times, 2 appears 10 times, 4 appears 16 times, 8 appears 15 times, 10 appears 12 times, 12 appears 8 times. So the number with the highest frequency here is 5, because it appears 20 times. Now we look for mean. We know that the formula for mean is the total series divided by the number of times it appears. But in the case of a table, it takes another formula. Instead of the normal summation x divided by n, you have summation fx divided by summation f. Now we prepare for fx. How do you get fx? To calculate fx here, we multiply f times x. So the value of f times the value of x. 10 times 2 here is 20. 16 times 4 is 64. 20 times 5 is 100. 15 times 8 is 120. 12 times 10 is 120 also. While 8 times 12 is 96. So we add this together, we have 520. Going back to the formula, summation fx divided by summation f, we have the value of summation fx to be 520 divided by summation f, which is 81. So we have the answer to be 6.41.